we get all those answered. All right, let's get started. So I'm Julia Carson, and I'm the curriculum developer who worked on this project. I launched our Physical Computing with Microbit course last week, and I'm really excited to share our second physical computing course with you today. So let's take a look at what we're going to cover. We're going to start with an overview of the course, who it's for, what it covers, and some important info to keep in mind when bringing this course to your students. Then we'll take a look at exactly where you can access all the needed materials for the course. We'll give you some information about our teacher testing group that we have for this Arduino course, as well as our microbit course we launched last week. And if you decide to join this, or you're interested in this, I'll give you some information about how to get involved. And we're going to end our webinar with a Q&A, so we'll make sure all those questions are answered by the time we're done. So first, we're going to take a deep dive into our Arduino course overview. So the Physical Computing with Arduino course provides a highly interactive way for students to apply programming concepts to physical devices. We're going to be using an Arduino Uno in this course, but as we see when we get to the materials portion, there are a lot of different brands that make devices that are very similar to the Arduino Uno. The course is meant to refresh and apply basic programming concepts in a physical environment. It's designed to be taught over the course of one semester to high school students. It's not really recommended to use this course in middle schools due to the level of complexity of the Arduino device, the immediate need for a breadboard when building circuits, and the more syntactically stringent C++ programming language. For these reasons, we recommend teaching physical computing with microbit to middle school students, but you can always ask our team if you have a specific need. The Arduino course is broken into 3 modules, very similar to our microbit course. In the first module, students learn the basics of the device by controlling LEDs and motors and using variables to control their programs. In the second module, students apply control structures to their programs along with sensors and additional components. They'll use temperature, light, and distance sensors to detect attributes of an environment and have their programs make decisions based on this information. In the advanced Arduino module, they're going to put all these parts together. They will research and teach their peers about an additional sensor that hasn't been covered in the course, follow step-by-step directions to complete a more advanced system of their choosing, and develop and present a final physical computing project. Throughout the course, students will test and run programs using a computer simulator as well as connecting circuits to run programs on their physical Arduino devices. So you can see here, the simulations are using breadboards and different components to build circuits with the Arduino on their computer, and they're able to write code and run the code on that simulation. And then students are also going to use those physical components to materialize that circuit and build it in the real world. In order to simulate circuits and programs, students will be using Tinkercad, and then in order to download the programs to their devices, they're going to use the Arduino software. So we've created step-by-step documents that will let you know exactly how to set up and use these programs. And these can be found at these links, as well as in the resources section of the course. We wanted to have a strong discovery learning focus in our physical computing courses. So we encourage students to hypothesize and test what commands do on their own through the use of what we call explorations. These step-by-step documents include diagrams, starter code, and questions to guide students to learn about the new commands and how they are applied in their programs without being directly told by their teacher. Each lesson in the course contains an exploration, so students are constantly exploring new commands to add to their physical computing toolbox. And I previously stated that this course is meant to refresh programming concepts for students. So in a very similar way to our microbit course, we expect that basic programming concepts such as loops, functions, if-else statements, and variables are already known by students before they enter this course because they're not going to be taught from scratch. So students should have seen these concepts previously, so they are already aware of how they work before using them with their Arduino device. There are quite a few CodeHS courses that provide this prereq information to students, as noted here. One important thing to keep in mind is that our Intro to Programming with Carol course does not include information on variables. So if you're using this course as your prereq, you'll need to supplement with some additional information about variables and parameters before students see those parts of the course. There's a few ways these prereqs can be implemented. Students can join your class after they've taken one of the courses listed, and this might happen if students are in high school and have already taken an Intro to Programming class. This could be with another teacher before your class, completed as a summer assignment, or if you're teaching a full year course, you could teach the main programming concepts in the first semester and then use this course as the second semester. An additional option is to have students learn these foundational concepts concurrently as they take the course. So this could be provided during another class period if your students are lucky enough to have 2 periods of computer science in their day, or could be threaded into the intro programming course. So we'll take look at an example of how that could work with our Intro to Computer Science in JavaScript course. So if you were teaching this course, this is the overall layout with the course content shown and each concept that students need to know in order to be prepared for the Arduino course. And here is where we could thread the Arduino lessons into the course to keep students engaged while still providing them with the foundational information they'll need to be successful. This will automatically show students how to apply the concepts they're learning and will make these foundational topics more relevant. And for all of those foundational courses, we have a layout or a structure like this of where those physical computing lessons and modules would fit into that foundational course. So you can always just reach out to us at hello@codehs.com if you want to know how to implement this with one of those other courses other than JavaScript. Now, in order for students to build physical systems, they're going to need materials. So at codehs.com/Arduino_materials, you'll find an entire list of materials used throughout the course, complete with suggested links, amounts, and important notes. It may seem like there are a lot of materials required, but the average price is below $5 per item, and students are encouraged to work in pairs or groups of 3 rather than individually, which will minimize the number of each item you'll need for the course. Throughout the course, students will work with LEDs, potentiometers, micro servo motors, thermistors, LCD screens, and more. They will combine these components with various programming concepts to complete engaging exercises, some of which are shown here. So before we move on to how we access these materials, let's see if we have any questions.
Yeah, Julia, we have a lot of questions on whether or not this is a course or you can run the Arduino using Chromebooks.
I believe that you can download the Arduino software on Chromebooks. That would be the only part that you would have to test. But if you go to that, let's go back to that link, Arduino_software, that would be the best place to see if you can follow those steps. And if you can, then you should be fine to use the course on a Chromebook.
Great. It looks like somebody just wrote in that said for Chromebooks up until now, you have to pay for Arduino software.
I know that Arduino also does have a web version of their software. So
yeah,
where you don't have to actually download it. All of our directions are going to be based on that downloaded program. But there is definitely a way. I just know that students need to create logins in order to access their account on for the Arduino software online. So as long as your students can do that, or you can make a class login, then that should work as well.
Yeah. Let's see. Just in light of COVID and virtual learning or different setups, do you think that individual work would be okay, or do you think it's something that students would want to, like, you would want students to be in pairs?
So definitely it's possible. I think because there are so many, you'll see even in this demo, you can add so many of those components in the Tinkercad simulated environment. I feel like it would be pretty simple to have students go through and just use Tinkercad to build their programs. There's, I think, one or two of our components that different sensors that are not included in the Tinkercad environment. So those parts would have to be skipped if students weren't using physical items. I think it would be a little tricky for you as a teacher to debug student circuit building virtually. You would probably want to set up like office hours or something with each student and go through so that they will make sure they aren't getting overwhelmed, because even you can see here there's a lot of wires and a lot of connections, and if students aren't fully understanding how the breadboard is connected, and if they plug a wire into 1A and then a wire into 1C, are they connected? Those types of things are definitely where students struggle, and you don't want that to make them less engaged or less excited about the course. So using the simulated environment, I would say, is the best bet if you're totally virtual.
Great. And then do you have a rough estimate of just the cost per kit for the student materials?
So currently, no, because the materials that we have, the majority of them are not sold individually. So even though you would really only need, 3 resistors per group or 2 buttons or 1 potentiometer, it's not usually available to buy one item, which makes it easier to buy class kits. But for like one actual kit where you only have one of each sensor, that's not really readily available. There are kits that on the materials link, you'll note at the bottom it has some links to pre-made Arduino kits. So those are going to include materials past what we require for our course. So they're going to be a little bit more expensive than if you were actually only getting the materials we technically needed. But those are kits that range from, I would say, $30 to like $60, and those could have so many more sensors in it, where in the third module, students are going to be exploring additional sensors. So you might want to have those on hand anyway. So I would say you definitely under $30, you could get all of the materials, plus more in one of those kit links that you can find at the bottom of the materials list.
Great. Do you know, we had the question about Chromebooks, but somebody else asked about iPads. Do you know if Arduino is compatible with iPads?
I wouldn't think that this course would work with iPads just because of the way that you need to use a mouse compared to just a touch screen, specifically for the Tinkercad environment. So I would check, try to go to the Tinkercad website and see if you're able to build a circuit that way. You should know very quickly if you're able to create a circuit using these materials and dragging and dropping and adding all the wires. You should be able to know in just the first lesson that we have. So I would test it out and see, but the dragging and dropping and all of that with touchscreen might be a little bit too advanced for the iPad.
Got it. Let's see. I think we can move on and I'll answer a few questions, just typing it out.
Perfect. And yeah, we have lots more chances to answer more of them. So let's go and take a look at how we can access all these materials. So right now our course is released in beta. So you can access it by going to codehs.com/Arduino/start. And you're going to be joining a section the way that your students join when you teach a CodeHS course. So you're going to need the class code of AD86B. And then you'll have access to all the student-facing content as well as the teacher-facing materials. And just a quick note, there are lesson plans, handouts, and teacher answer keys for the first 2 lessons of the course, but the rest of them are going to be coming in the next few weeks before we launch the course fully in July. So right now you can access all of the content at codehs.com/Arduino/start. And just a note, when you go to this website, it will either prompt you to log in if you have an account or sign up if you don't. So if you want to access the content and you don't have a CodeHS account yet, you'll be able to create one and then enter the class code. You can view the syllabus for the course by going to codehs.com/syllabus/8050 or directly from the Arduino marketing page at codehs.com/info/curriculum/Arduino. These items note much of the information that are being shared with you here, so they're great resources to get started with. And before we move on to our teacher testing group, do we have any more syllabus, marketing, materials specific questions?
Great. Yeah, so I have a question. Do you have to subscribe to Pro to run this course?
Good
so the
question.
answer, oh, you
Yeah, so all of our courses, all of our curriculum is totally free. So you can access all of it and create a class and have students join once we launch our full course in July. You'll be able to create that section of your students. All of that is free. The Pro will give you access to more advanced teacher tools and grading systems and additional resources. But all of the content you can use with your students for free even right now.
Great. Just to note, so all of the links that Julia mentioned, they are all in the chat. So you can check those to copy paste any of the links. We will be sending out a recording of this webinar to anybody who RSVP'd later this week. So you will be getting a copy of that. So yes, all of the links in the webinar will be sent to people. And I posted the class code link into the chat. I think we can continue.
All right. So now let's talk about our teacher testing group and how you can get involved. Because this course is so much different than the other courses we offer on CodeHS, we want to be sure that the materials we're providing to teachers and students are highly effective, informative, and fun. In order to be sure of this, we'd like to connect with teachers that expect to use this course with their students on a more individual level and give you a chance to be heard. We understand that commitment levels and available timeframes may vary greatly depending on your situation, so we have multiple ways to get involved. Testers can be given access to our feedback system, where comments and suggestions can be left on individual items as you go through the course, or you can choose to be a part of phone calls with the CodeHS developers and other testers. So I've already been receiving a lot of really good feedback about our microbit course and things that teachers are noticing or thinking about with their specific students. Those are all really important and helpful to us. So if you're interested in getting involved in this testing group, please fill out the Google form found at codehs.com/Arduino/testing. And I thank you in advance for considering joining this group to make this course as great as it possibly can be. And now we can take any of our other questions that we have.
Great. The first thing is, it looks like I accidentally posted those links just to the panelists, but I did just post them to the panelists and attendees. So everybody should see those links now, and I apologize for that. So you should see those links now. Can you put back up the screen that showed the lesson, or how you would structure lessons if you were to weave in the JavaScript course?
Is this the one?
I believe so.
Perfect. Yeah, and we have this laid out for our Python course, our Tracy course, our Carol course. So if you want that information, just reach out at hello@codehs.com.
Great. I'm also posting the testing group link into the chat. Let's see. Could if somebody has a colleague who's not in this webinar, but they might be willing to beta test, can they send that link to their colleague?
Yeah.
Great. If somebody were to weave the JavaScript and Arduino lessons together, would this be best accomplished over a year or a one semester course?
So definitely it would take a pretty hefty year because our Arduino course is meant for about a semester and our JavaScript course is meant for about a year. So if you were teaching this type of a structure in one class, you might have to remove some of those challenge modules. In our JavaScript course, we have a lot of additional practices and extra challenges depending on your students and how fast they're getting through material. If they're also learning virtually, you know, a lot of those challenges might be done at home. But I would say this would be a pretty substantial amount to cover in a year. So you would want to definitely make sure you track that out before you get started.
Great. This is kind of related to something that came in earlier, but this teacher says that they'll likely be distance learning. Other than teacher demos, are there resources for modifications in light of COVID?
So our goal is to make sure that we have ways that these courses can all be given in these scenarios. We have been hearing a lot of different ways that schools are going to be working next year. Some where you would have like 1 day or 2 days a week of students in your classroom. This is a very specific type of course because it is the one course that requires materials and requires students to like physically create things. So in that case, I would say having that in class time set aside to just actually do the physical building of things and having students do all of the pre-work at home would be the best way to implement that. If there's no way for you to physically see your students, if it's completely distance, like I said before, I think the simulation track would be a little bit better than using the actual materials and having them build their devices, or just switching to the microbit course, which is if you have students who are brand new to circuitry, brand new to physical computing, any of that, it might be a really good idea to use the microbit course, which still is teaching the same concept. So though that course, we are marketing it as a middle school course, it for sure still teaches the same concepts to students, and it just makes the circuit building a little bit easier because the breadboard isn't required until the very last module. So for a complete distance scenario, I think that would be your best bet, teaching these programming, the physical computing concepts through the microbit course.
Great. Let's see. Which prerequisite course of the ones that you suggested takes the least amount of time?
Good question. I would say our Carol course is the shortest, though there is that extra note that the variables the variables and parameters are not included in that course. When I was teaching engineering, I used the Carol unit as a winter break assignment before we started robotics. So this definitely can be assigned as a summer assignment or something like that for students. I would say it takes about 2 to 3 weeks, depending on how much of the additional components, supplemental components you include. But students could definitely get through that in 2 to 3 weeks. And the Tracy course is the second shortest. And that course also includes variables and parameters, so you wouldn't have to add those in on your own for students.
Great. A question on just course content. So does this course include how the electrical systems work as well? So like, what is a diode, Ohm's law, and the like?
That's a good question. So our goal for this course was not to include or to brush over as much of that as we could, because we want to focus on the computer programming portion. So students are at the very beginning of the course learning how or seeing how a circuit won't work if it's not fully complete. Those very, very basic concepts are there. And then they are also introduced to the layout of a breadboard because they're going to be using them very substantially throughout the course. But all of the additional electrical components and topics are definitely not touched on by us, but it opens the door for you if you are a teacher who does have that knowledge or needs to include that with your students. You can definitely very, very easily discuss those as you're going through the course content.
Great. How would you manage pacing for this course? So there's a wide range in student effort and kind of background when it comes to breadboarding.
My answer would be different depending on if you're virtual or not, because it's much easier to have students pair program and make sure that you are being able to pair different types of students together in a classroom. Virtually, that's a little bit more difficult, but in general, I would say I would just put the note out there that students might have not shown interest, in a previous way, but these courses are completely built for them to be excited, and through those explorations, they're able to find the answers themselves rather than being given them or being told this command does this, now use it to do this. So you might see some of those students who were slacking a little bit more or less interested. They might get more interested in a course like this. That being said, you have a lot of options of how to keep students tracked on CodeHS. There's a bunch of tools that we have in our system where you can lock different things until students complete, lock them for a certain time, or assign additional content. So we're working on building out supplemental material as well, which would be really good for students who are really quickly going through material or really want extra knowledge. There's so many more things that the Arduino can do than are in our course because it's just such a hefty device. So the goal is to have a lot more of those components in our supplemental section, which would really help keep students involved, even if they're really excited and going through really quickly. But yeah, I would say pairing students together where a student who really has that breadboard knowledge is able to help a student who is brand new to that. And the goal is through all of our materials to not really expect students to fully on their own build these circuits. Every circuit that is required of them is written out, each connection, every wire that needs to go in each port, and with many, many images. So as you go through the course, you should see a bunch of those things. And if there are more things that you think would help those kind of students who don't have knowledge of creating circuits, which we're expecting students to not have before they join this course, join our testing group and leave us feedback about that, because that would be really helpful.
Great. In terms of content hours, what is the course? Do you know how many contact hours roughly we're estimating?
So if you go through the syllabus, you'll be able to find exactly all that information. I think, yep, right here. So we have 35 to 50 based on the content that is created in the course. Though the additional, those projects at the end of the course, there are modifications that you can make to increase what you're expecting of students. For example, one of our challenges in the third module is to create an elevator an elevator simulation. So students are going to write the code and have the elevator output to an LCD screen, but they have the option to then find a way to physically build that elevator and use those sensors that they learned about to figure out how the elevator can move up and down to different floors. Just the addition of building the device rather than just simulating it with an LCD screen could add an additional week or two of content. So depending on what you need, what you're looking for, you can definitely alter the course to fit probably anywhere from a quarter to much longer.
Great. What type of careers might this prepare a student for?
Good question. So there are so many different things out there where students can go with physical computing. IoT is so large in our world right now. And seeing how computer programming fits with the physical world is a really important thing for students to see. If they're interested in, more of the engineering side, that robotics track is bursting right now. There's so much out there. But even if students see these building these circuits and they decide, they really like the electrical component, they want to do electrical engineering, you still need the computer programming portion as well. So there's a bunch of different ways that students could go out from this first physical computing step.
Great. If students have completed like an intro to programming course using Scratch, would you consider them prepared for this course?
That's a good question. So Scratch just uses blocks, and this whole course is going to be in text. So I think that it would definitely, the concepts, if they've learned loops and if-else statements, and they understand how those things work, they'll definitely be able to jump into this course. They just might need a little bit extra help with the syntax because syntax, especially in this course, is taught in C++. That's the language that's used in the Arduino environment. And it's a little bit tricky. So it's pretty heavily syntax focused. So I would just make sure that you're available to fully flesh out all of the commands and make sure students understand that as they write commands, they really need to pay attention to exactly how they're written rather than, when they're dragging a block in, there's not much that they need to pay attention to in that case. So just the syntax part, I would say, would be the thing you want to focus on.
Great. We have, just in regards to the language, so is C++, would you say, is Java, JavaScript, Python more similar than the code that they would use in Arduino?
Yeah, C++ as a language is most closely related to Java. JavaScript students will see very similar things. There's just a few differences with how parameters are written and how functions are defined, which is closer to the way that they are in Java. But even if students have learned their intro programming in Python, it's as long as they understand the concepts, they should be able to switch over to the language and see those differences pretty easily.
So if people are having questions about like what does gradebook and grading look like in terms of the codes, and students aren't going to be coding in CodeHS?
That's a good question. So our exercises that are in the course are all going to have an area for students to paste their code so that you have access to it and it is saved somewhere. Students are going to be working between our CodeHS platform and the Tinkercad platform. So they'll be given all of the information and the resources and the directions in our CodeHS platform. And then they'll head to the Tinkercad system, and they'll be able to build out those circuits following the directions and layouts that we have provided them. They're going to build those circuits with all of the additional components, and they have the ability to develop their code in that platform. And then once they know that their code works using that simulation, they'll be able to download it to their device, make sure that their device is working with that program. And then once they know that they have fully completed the exercise that is being asked of them, they're going to paste that code into the CodeHS system, where we have a program type where the syntax coloring is still going to be the same. So you'll still be able to see it formatted the same way. If you actually wanted to run the code, you would paste it into Tinkercad in order to do that. Or you can visit the student's Tinkercad simulation through Tinkercad. So if you go to this Tinkercad link, you'll be able to see how you would set up a class, and you would be able to see all of your students and all of their work. And you will then be able to grade all of those exercises, all of those components for students in our CodeHS system. And that grade is directly related to that exercise where the students have pasted their code.
Right. So just to clarify, so they will basically use Tinkercad to run their code, but then they're going to copy it to CodeHS so that teachers have access for grading.
Yep, and you will still be able to give feedback on that exercise, have that conversation with students about that topic, that exercise that they completed.
And do you know if students can use Autodesk Inventor instead of Tinkercad, or as well as Tinkercad?
So Tinkercad, what we're using it for, so Tinkercad has a lot of different things that it can do. So one of the uses is building 3D models like Autodesk Inventor does, but an additional component of Tinkercad is building circuits and simulating them. And from what I've used of Autodesk Inventor, it doesn't have that capability. So you would just use that section of Tinkercad, which is the circuitry area of the website.
Great. Could you do a weave-in with Mocha or one of our Java courses?
Yeah, we haven't done that, but that would cover all of the needed concepts. Currently, we don't have, for like the AP courses, we haven't integrated, made an integration for the physical computing courses, just because the AP courses have really high demand. But the other non-AP Java courses that we offer, we can definitely do that, because they can be altered to just hit those concepts that students will need before they get into the physical computing portion. The one thing that I would caution against is that in our Java course, we're teaching a lot about classes and objects, and that is not needed in the physical computing course. So I would just make sure that I would have to go back and double check that there's a way to incorporate loops and if-else statements and all of those things students will need to know without bogging them down with those higher object-oriented concepts.
Got it. And then for the actual exercises, will we have problem guides available for teachers for all of the C++ programs?
Yeah, good question. There will be, right now we're in the midst of developing all of the problem guides and lesson plans and handouts. And you'll notice in the first 2 lessons where they're completed, for like the explorations, there's a teacher document as well that will give you all of the answers, as well as an additional tips and things that you'll need to know how you should probe your students, how you can make them get to the correct answer. And in our problem guides, you'll be able to see for each exercise students are completing, the motivation behind the exercise, some questions or frequent mistakes that students will make or bugs that you can expect, so that you know how to help them fix those as well. So yeah, those will all be in the problem guide.
Great. A few questions about AP courses and integration. So first of all, would this be a good fit for the AP exam if people, have school in session for a month or so after students take the tests?
Yeah, I think that's a perfect way to bring this in, because students already have seen all those concepts, and now this is a fun way for them to get to apply them in a totally new environment. Yeah, I think using this after the AP exam is definitely an awesome idea. You'll probably just have to, students will most likely be able to get through Module 1 and parts of Module 2, depending on their level and how comfortable they are with all of the concepts. But they probably won't be able to do any of the projects at the end in Module 3, because those are pretty time consuming.
Got it. A hardware question, just a few questions on, there are some, I guess, Arduino knockoffs that use CH40 communication. We might not know the answer to this, but do you know if that would be compatible with this course?
So I'm not sure about CH40, but I know that if you go to the materials list, we have linked to a few other knockoffs that have been used by our team as we're developing this course, and we know they are compatible. One of the companies off the top of my head is Elegoo, and they are half price or less than an actual Arduino Uno. So using those knockoff brands for sure, most of the time are totally fine, as long as they note that they are similar, trying to be similar to the Uno version of Arduino. Arduino also has a Nano device, and that device won't be able to be used for this course. So if it's trying to be like the Nano, then you wouldn't want it. But I would say a lot of those can be found on Amazon, and now you could test one out, make sure that it works with one or two of the circuits that you're going to build, and then you should be set to use those for your course.
Great. We had one question that I can speak to because it's regarding the AP CS principles. So the question was, can you use the microbit course as the programming unit of AP CS principles? So our Arduino course as it exists will cover some of the programming pieces of the principles framework, but it won't cover everything. So I would not recommend it as a substitute. I would say with some heavy supplements, you could use Arduino to cover all the programming, but our curriculum as is will not cover all of the concepts. Let's see. Just a question. We did have a note that knockoffs can be used, but you may need additional drivers. And then the knockoffs that you were talking about, that should all be in the materials list, correct? And that's posted in the chat. So anybody who's curious about all of the spelling can check out that list. Great. How deep does the curriculum go into classes, objects, methods, and instances? If kids are competent in C#, will they be able to better practice and understand these concepts in a more concrete way with this curriculum?
No, we don't touch on any of those concepts currently.
Great. Of course. Let's see. And then the materials list, the like breadboards, jumper wires, LEDs, resistors, those are universal materials, right? These are not specific to the Arduino.
Yep. And you'll find all, as you can see, all those links to various items that can be used. And you'll see in those, all the note section, if you if there is something to keep in mind, like you need to have this specific type of device, it will say that in the notes.
Great. Let's see. Will we have a Python and Arduino combo curriculum? So maybe you can go back to the list of all the courses that we.
Yeah, so we do currently have an integration of how to concurrently teach the Python course and the Arduino course, and you can reach out to hello@CodeHS and get all that information.
Great. We did have a question on, will there be teacher training provided for this course? The answer is right now we don't have a professional development related to this course. However, it is something that we are interested. We definitely see this as a need. This is definitely more complicated than the average computer science class, just getting started with materials. So we are hoping to have some professional development for that.
Yeah, and I would definitely suggest joining that testing group so that you can get access to the feedback system, because it would be really helpful. My goal throughout as I've been creating this course is to try to make it as easy for a teacher with no background in physical computing to teach this course. So if you have, if there's any parts of the course where you need more background or more scaffolding, that all is really, really helpful for us to know. So you can leave that all in the feedback.
And then do you know if the Tinkercad also talks to Google Classroom, or do they just have the Tinkercad Classroom? We might not know that.
I'm not sure.
Yeah, I would check that out.
But you also wouldn't want, the Tinkercad Classroom would be a way for you to have all your students in one area where you can visit their circuits that they're building and their code, but you aren't actually assigning anything on Tinkercad, doesn't have those capabilities. So it's just a way for you to be able to have a look into what your students are doing.
Great. And then besides the elevator project, can you go over, maybe talk about a few other projects that students are doing in this course?
Sure. So students are also asked to develop a watch using an LCD screen. So they're using one of the commands that counts time in milliseconds from when the program started. So they're going to use that timer to develop a watch where students will be able to use buttons to set the hour and the minutes, and it will keep track as it continues. And that challenge is currently just for students to build the circuit and the program, but as in the elevator, they can also be tasked with using tilt sensors to have their watch turn on when they turn their wrist, using engineering to create some sort of band so that it can be put on and taken off. So all of those things can advance that problem. And then students are also asked to go through various websites where there's a lot of step-by-step projects already out there. So something like Instructables or Hackster. And they'll find a project that they want to try to follow the steps to build. A lot of those projects do have images and directions, as well as schematics and code already written out. But having students go through the process of following someone else's directions to actually get to that final project is definitely something where they're going to learn a lot, and then they're tasked with rewriting the directions so that it will be even easier for a student who is in their same case to follow and build that project. And then at the end of the course, they're going to build their own final project, which they'll be able to incorporate any of the sensors and components that we've learned, as well as sensors that their peers have taught them about during that module. So they'll have a lot of options of how to build, options to build whatever system they're interested in.
Great. We had a question, does the course cover like how to read schematics, or is it just kind of using a visual to set up a breadboard?
Yeah, we don't cover schematics at all. It's all just images to make it as simple as possible, so students are not trying to learn multiple concepts at once. They're focused more on actually learning how to program these devices and use those commands.
Great. So we don't have other questions open right now. Maybe we can stick around for a couple more minutes to see if there are any lingering questions, but otherwise, if people don't have questions, thank you so much for coming to the webinar.
Yeah, thank you. And we have a bunch of other courses that are launching. So we've already launched our Fundamentals of Cybersecurity and our Microbit course, our Python 3 course. Next week, we're going to be launching our Advanced Cybersecurity and our Web Development courses. So if you are interested at all in hearing about those, you can go to codehs.com/webinars, and we'll stick around if there's more questions.
We had a question about the links will be emailed. So we will be sending out a recording of this webinar, as well as all of the links and resources that we shared out. So if you didn't catch those URLs, don't worry, we will be sending those out to people. Let's see. We do have a course we have a video game design course. Somebody asked if we have a course in gaming and apps. So I would say our JavaScript course is probably the closest in terms of students will be creating animations in games, and that's kind of our best beginners course. We also do have a mobile apps course that is more on the advanced side, so it wouldn't be the first course that we would recommend students take. Somebody asked, will this course be available in August for students?
Yep, so we're going to be launching our full version of this course in July. So be on the lookout for that.
Great. When will teachers be contacted if they're going to participate in the teacher trial group?
Definitely sometime early next week, you'll get an email.
Great. I would say we have a few other questions. The address to request curriculum combos, I'll just go ahead and type into the chat, but hello@codehs.com is where you can direct any questions that you have. I think that's about it. So I would say we can go ahead and wrap up.
All right, thank you.